Okay, in this second example, we want to go ahead and take a look at converting from rectangular coordinates to polar coordinates. So in example A, we are given the rectangular coordinate 5, -9. So the very first thing that I'm going to go ahead and do with these types of problems is to go ahead and just give myself a rough sketch of what it would look like on our coordinate plane. So just a rough sketch, I'm going to go over 5 and then down 9 units. So I know that my point is going to be somewhere in quadrant 4. So we'll come back to this idea in a second, but we just want to make sure that we get used to finding this location. Okay, so the first thing that we need to do, once again, if we are starting with x and y, we need to make sure that we can find our r value and our angle measure. So in order to find our r value, we are going to use r equals the square root of x squared plus y squared, which we get from the Pythagorean theorem. In order to find our angle measure, we are going to use theta equals tangent inverse of y over x. Okay, so going ahead and plugging in our information, I'm going to find r first. So I should get r equals 5 squared plus -9 squared. I know that this is 25 plus 81, so that should reduce down to the square root of 106. And if I go ahead and evaluate that in my calculator, we should get an r value of about 10.3. Okay, so that's the first part of the problem. For the second part, I need to go ahead and figure out my theta value. So I'm going to use my calculator. I do want to make sure that we are in degree mode. So I'm going to go ahead and evaluate tangent inverse of -9 over 5. And when I plug that into my calculator, I should get an answer of -60.9 degrees. Now going back to this picture that we drew earlier, we knew that this rectangular point was located in the fourth quadrant, and we just wanted to make sure that the angle measure that we find is also in the fourth quadrant. So if I'm starting on a positive x-axis and I rotate down -60 degrees, approximately -60 degrees, we should wind up in the same area. So this, in fact, will be our angle measure. So I can go ahead and write this as 10.3 comma -60.9 degrees. Okay, once again, I'm going to have you go ahead and pause the video and try part B. For part B, we want to convert point T, which is -5, 14, into polar form. So go ahead, pause the video, give it a try, and as soon as you are done, make sure you come back and check your answer. Okay, starting off in problem B, I went ahead and I got a rough sketch of the point that I'm given. So I know I have to go left 5 units and up 14. So I'm located somewhere in the second quadrant. So once that idea is in mind, I can go ahead and continue on with the problem. So the first step, we want to go ahead and plug in our x and y value to figure out what r is. So -5 squared plus 14 squared should give us the square root of 221. Simplifying that, reducing it down on our calculator, we should get an answer of approximately 14.9 units. Okay, if I come back and continue on to find theta, I want to go ahead and plug it into my calculator, tangent inverse of 14 over -5. We should notice that we get an angle measure of -70.4 degrees, and this is where we run into a little bit of a problem. Once again, if I'm starting at my positive x-axis, my initial side of an angle rotation, and if I rotate -70.4 degrees, I'm going to wind up somewhere in the fourth quadrant. And we know that we have an issue because our point should be somewhere in the second quadrant. So if this is the case, if we wind up in the wrong quadrant, we want to go ahead and add 180 degrees to whatever our angle measure is so that we wind up in the correct location. So in this case, if I add 180 degrees to -70.4, we should wind up with an angle measure of 109.6 degrees. So the polar form of my equation should be 14.9 comma 109.6 degrees.